Welcome everyone to our final of the AI Challenge Days 2020, the first hackathon organized by the AI community OWL. So it's really an honor for me to moderate this pitch session for all of you. My name is Lucas, and I was one of the co-organizers of this hackathon, and I was really happy to see so many people working here very hard for the whole weekend. So we had 3 challenges. We had 6 teams that were trying to solve these challenges, and now it's the time to give them the stage to present their results. So we are very happy that all teams did the work until the end, so we didn't lose anyone. And now we are very excited to see your results. So, like I said, it was a lot of work. We had a lot of sessions in the morning, in the afternoon, and also in the night. So everyone were active. We have used our platform. They have also used their own platforms where they prefer to work. Yeah, it was working, I think, quite well. Yeah, and now I would suggest that we will go through the first video, which let's say explains what was the first challenge in the smart building. And so everyone who was not following us before, he can also get to know what was the idea of the challenge. And then afterwards, we will have 3 pitches from 3 teams, and they show us how they solved the challenge. So Arne, can you please play the video?
The challenge on the subject smart building is about elevators. But before I go into more detail, let me give you some background information. Phoenix Contact is known for industrial products and applications, and that is also what made the company grow. But Phoenix Contact also has recognized the change of time and the era of digitalization. For this reason, they don't just concentrate on their core business, they've already branched out into various digital business areas such as building automation. In the city of Bad Pyrmont, they've built a state-of-the-art building solution center. All facilities in the building provide a total of 30,000 data points. The building automation system Emalytics networks all facilities and normalizes that data. This enables every process to work together: ventilation, air conditioning, lighting, and more, to ensure efficient operation of the building. But what do we do with the elevator? We monitor the elevator's driving cycles, and thereby we automatically control the maintenance intervals on demand. Also, we have autonomous driving robots like this wiping robot, which can navigate through the floors by using the elevator. Those are our applications on the elevator, and next we want to bring some AI to it. Therefore, we need your help. So, let's head back to our challenge. The goal is to analyze the movement behavior of the elevator and predict its movement and position. These predictions can be used to better position the elevator and save waiting time. We provide you with the data records of the past 2 to 3 years, and we will explain you the tables in detail. We really hope that many of you will come together for this challenge. So, we look forward to working with you and having a lot of fun doing so.
Okay, great. Thanks for playing the video. And now I would like to welcome the first team building, Akhil, Cedric, Bini, and Priyanka. You can now show us your results.
Yeah, sure. So let me share my screen. Yeah, myself, Priyanka, and we are a team of 3, Akhil, Priyanka, and Bini. So as we already know the business goal, let me quickly overview the business goal here. So we are concentrating here to reduce the elevator waiting time by predicting the next floor position. So that was our business goal. So going to the next slide, we have given our approach there. Like what are all the different steps we generally perform to do some AI model or to achieve the final goal what we have reached. So the first point was the data cleaning, which includes like all the cleaning missing values, filtering all the relevant data, understanding the data and all. Coming to the next part, data analysis, we understand all the insights what given out of the data and visualize the data to understand what exactly the behavior was, dividing the data into different time zones, and then we visualized it to understand for which hour the data was behaving in which way and all those stuff in data analysis part. And from there we moved into the model approach. So in model approach we took like we tried to implement different approaches here. As the data was not supervised, we cannot go with the supervised algorithm to train our model. So and also even to forecast we cannot go with the time series because the elevator behavior was completely random, so we cannot go with the time series to forecast. So that's the reason we chose our model as the probabilistic one of the model which generally uses based on the which generally works based on the probability function. So our prediction, we come up with the probability approach, finding by the highest probability for like the position of the floor at that particular time where it was there and where the probability of chances can be requested. So that's what our approach was. And also you can see here a simple small graphs where as I talked, the data was not inconsistent, the data was completely inconsistent. You can see from these graphs that there was lot of fluctuation going on. So that was our approach here. And going to the next slide, we have put some complete we can say graph there. So in that graph, can you go to the next slide, please? Yeah, so here if you can, and we tried to show you some graphical representation how our data was being moved and how the graph was fluctuating and all those things. So here you can see the elevator positions from 9 to 10. So that too in between 2nd January to 10th January. So in this time, if you see, the graph was moving in most of the time. It was starting from the first floor and it was going to the second. So that was the peak it was going. It was going from first and it was touching second, and again later on it was moving to the other floors. So most of the times it was picking the first. So that's the reason we have given in the first. So this was a sample data for giving the better understanding. So this is how our data was actually being there. This is for only 1 hour, but for other hours it was again varying. So in the next slide, that was the that I would like to conclude saying that based on our probability algorithm, we just done a lookup table kind of thing, and we made a decision. And you can see the decision like if the current floor of the elevator was 7, then we should move the elevator to the second floor. And if the current floor was second, next position will be 3. This was only for in between 9 to 10 timestamp. So this was a sample example to give a better understanding. So in the similar way, for each hour there are different certain positions which we predicted that was already uploaded there in the location. So and also beside that you can also see the graph variations, how it was fluctuating, which was completely obeying with the table what we are showing there. So yeah, I can say that yes, this was pretty much what we have worked on. Based on the probability theorem approach, we decided our model, we trained our model and make the evaluation. Yeah, so that's it from our end. If you have any questions, we can have it.
So thank you, Priyanka, and thank you for the whole team for your presentation.
Yeah.
Do we have some questions from our experts?
Yeah, Priyanka, thank you very much. I liked it that you also gave us your thought process, which was very nice and understandable. So my question is, in your opinion, which steps need to be done to implement an application based on your work? So how would you proceed on a real elevator, so to say?
To proceed on the real elevator, I really feel that we have to work on the data level first, because the data which was given right now was completely inconsistent and there was very lot of missing data. So if data before in the initial call, while the discussions were happening, I got to know that there is some algorithm which was written for the algorithm inside to move in between the floors. So that algorithm needs to be tweaked, I guess. And also, while the elevator was moving, there is a bug like saying that it was going to all the positions. It was like mentioning, let's say the elevator was moving from 1 to 5, it was giving all the floor details, 1, 2, 3, 4, and it was giving 5. So that was a bug, I feel. So we need to fix those errors. So we need to mainly concentrate on the data cleaning part to make our algorithm more useful and give them more clear prediction. And once the data part was ready, like the data cleaning was done and the correct data we are having, then we can apply more algorithms to that. So and that is what I'm feeling in the first step.
Okay, so in your opinion, there's more data cleansing to be done, and that would polish your accuracy.
Yeah.
Mm-hmm.
It would be great if everyone who is talking just turn on the camera. And yes, I think in this case, it would be very helpful to have some domain expert here to, let's say, to clarify this kind of points. If you would like to, let's see, continue with that, so that he could also explain if it's some bug or not. So I think it might be very helpful to get rid of these kind of things. And is there any other question to Priyanka or the team? So what was the main challenge? So the most challenging for you, because you had a team composed of people from different places. Was it an easy task to organize yourself?
Yes, we managed to organize through Google Meetup. So we conducted meetings very often and see what is the progress. And also we divided the task among ourselves so that it will not get delayed in the work and task can be delivered in the correct time. So the main challenge what we faced was the handling the data, as the data was completely not that clean. So handling the data took more time for us, and also handling the errors and all, making the final code and understanding the business objective clearly at the initial point. We took help from Telman mostly to understand what exactly the business goal was, and also Stephen helped us from the approach. So we had many questions at the beginning, but from their expertise we got all our questions to be answered and we move forward. So that's how we managed to work in the team.
Great. Any other questions to Priyanka? Okay, so it's not the case. So thanks a lot for your work. Thanks a lot for your engagement for the whole team. I think it's a great result, and I would suggest to change to the next team.
Yeah, sure. Thank you for the opportunity for giving me to explain everything what we have done. Thank you.
Thanks a lot. Okay, so I would like to welcome the next team, Team Building 2, with the team members Andrew, Marcel, Gordon, and Tom. And I think Andrew will present the pitch presentation. So hi, Andrew. How you're doing?
I am muted. Sorry. Hi. Thank you.
So you can see
Can you hear me?
everything. Yep.
Yeah, okay. And let's go ahead and share. All
So
right.
5 minutes time.
Can you see?
Here we go. Yes, we can see you.
All
And we
right.
can see also the presentation.
So yeah, we had the same task as the previous group. We are team elevator pitch. We're a group of either former students or current students from Lemgo. So our method to go through this project was we did first a data exploration step. Then we went into the data pre-processing so that we could feed this data into our models. Then we did training and lots of different kinds of training, playing with our models. And then at the end, we did some evaluation to see what fit best. So as like with the previous group, one of our biggest problems was the data. We spent a lot of time in data exploration and data pre-processing. Because like they said, it's pretty inconsistent, and we broke it into 3 different types of data. So there was data where we only had driving cycles and the times. And then the second set was driving cycles plus the floor numbers plus the times. And then finally, all of the data that included also the requests. And because the task was to predict the next request, we were only really able to use this last data set, and it was only about 6,000 points. And this kind of hurts us later on in the training, and I'll show you why. Just some quick analysis. We broke the data down into unique requests because of the way that the data is logged. Sometimes, excuse me, sometimes the PLC or whatever was recording the data recorded multiple instances of a request, so we had to cut those out. And we also had to make sure that we were only looking at requests, because in the first floor, it's where the elevator parks, so it will go back to the first floor by itself, not on a request. So we very specifically had to sort of separate that to make sure we were getting accurate information about requests and not just where the elevator is sitting, or else it would bias our models later on. So then our data pre-processing step, we had to remove a bunch of NaN variables. We found where all of the rising edges were for the requests, because as I said, there were multiple instances. We added direction changes into the data. Then we generated all of our labels, normalized the floor levels, ignored the return to home. That was another very important one, like I just mentioned, so that we did not end up skewing our data to the first floor. When I say first floor, I mean the basement. We reoriented all of our floors so that the basement was 1 and the attic is 7. So if you're looking at these charts here, 1 is the basement, and we don't go to 7 very often. And this graph is a subset of our data that we, these are our labels. So the blue line is our labeled data so that we can do training, and then for the requests, and then the yellow line is where the elevator actually moved to. So our training started out not going so great. Our models were not learning very well. Then our model started to learn a little better, but our validation was pretty terrible. And then we had a textbook case of learning and then suddenly not learning anymore. So because we were overfitting, and we had quite a bit of problems with overfitting because we just didn't have enough data. To choose from. We only had, I think, 1,000 unique data points where the elevator was requested to go someplace. But after some time and working with it, we were able to get some more consistent training to reduce our weighted average distance. So one of our loss functions was one of our metrics, sorry, was this distance until the actual choice. One interesting thing that happened is the final data sets that we're supposed to test against actually weren't valid for us. We used a sliding window, and our sliding window was too wide for many of the those training data sets, or sorry, those validation dating sets. And I'm over time, but this is the results. So basically, we found that we might not need a model for any of this. There could be large gains potentially found just by simple data analysis. The small data set made it hard for us to train because we ended up overtraining way too often. Some of the test sets were incompatible with our models. And then finally, our main recommendation is to stop parking in the basement. Because as you saw in that first chart, the most requests come from floor 2. So an improvement already would just be move the parking position to floor 2, and you would greatly improve the wait times. So I think that is our conclusion.
Thanks a lot, Andrew. It was a really nice presentation. So it seems that the data, the input data that you got, it was this, let's say, also an issue for you guys as in the previous team. Yeah,
and we spent a lot of time.
So I guess the domain expert would be, so if you would have some domain expert, let's say, in the team, it might be probably a bit easier to approach that. Okay, do we have some questions from our experts? So if yes, then just unmute your mic and turn on your camera.
Yeah, thank you, Andrew. You can tell that you were working very targeted. You had a good focus, and you knew what your target is, and you can really tell from this pitch. So my question, actually, I have 2 questions. You already mentioned that sometimes you do not really need the AI only. You can make some adjustments that will improve the outcome even on, without using AI. How would you value that in this case? Comparing simple adjustments like the parking position and your work on the AI.
Yeah, so as I understand your question, how could we not use the AI, or
how would you compare the value between using AI and simple methods like changing the parking position?
Yeah, to be honest, I would think that just changing the parking position would provide a lot of benefit. One thing we talked about in our group was that if we had good data from, say, all of the elevators, from all of the conference rooms, from all of the not proximity detection, the detections throughout the building to know where people are, or if there's conferences going on, then we could maybe use AI to move around the elevator in these special cases. But with this very limited data set, the AI wasn't particularly helpful, and it would probably be best actually to just move, like park it on the average requested floor, which would be floor 3, and then you have the most probability to have a shorter waiting time. Yeah.
Mm-hmm. Yeah, and the second question, basically the same question as for Priyanka. Looking on the added value we wanted to achieve, how do you imagine to implement your work into an application that can be put into operation in the real elevator?
Okay, so it depends on which approach we take. If we take the approach where we just change the park floor, then you go into the PLC and change the park floor. Yeah. But if we want to actually implement this, then we could maybe integrate it with the Emalytics platform. And I don't know if the Emalytics platform is doing any control of the elevator position, but that would be a good place to place the model
Mhm.
to dynamically change the parking floor.
And in this case, would you have to make some adjustments on your source code? Like, I mean, now you
For
have
sure.
the, yeah.
For sure, yeah. Because also there was so much data pre-processing that we had to do, that I would think that, yeah, we would probably have to do some source code changes. I don't know if the other guys, do you guys have any comments on that?
Maybe if I'm allowed to step in, I think we automated a lot of our data pre-processing, but yeah, 2 days are not enough to test this really into depth. So I think the first step would to be automate the pre-processing so that you can gather more clean data, then put some time in yeah, fine-tuning the model parameters if you actually want to use AI. And yeah, that would be the 2 big steps, I think.
Yep.
I see. Thank you very much.
Great. Thanks for the question. Thanks for the answer. And to all of us following at YouTube, you can also post your questions in the YouTube channel. There's some small delay, so I will try to catch up with the questions so they're not always, coming on time. Yeah. Any other short question at the end?
Not a question mark, but may I have a short comment? So this is Thomas. Thanks a lot for both of you, Priyanka and Andrew, for the great presentation so far. And we would like to ask you and all of your team to stay all in the line, and all other teams coming as well. We would like to have some pictures of the teams at the end.
Okay.
Yeah, so we will make a screen copy of all of you in the end. Okay, great.
Okay, so if there are no more questions, then thanks a lot again to Andrew and the whole team. And now we are going to the last building team with Juliane, Maciej, Piotr, and Wolfram. And Juliane will, I think, make the presentation. So it would be great if you could also turn on your camera.
Wait a second. So camera is on. Can you see what already my screen?
Yes, we can see your screen, and
okay. And you can hear, obviously.
Thanks. Yeah. So good luck.
Let's say one word about the other presentations. Really, a lot of the discussions you had in your teams, we had also in our team. Looking on the time, we will really be very rough in our presentation. All the details we faced in a very similar way also. So we are the team number 3 in the building challenge. And let's say our keynote at the end is how the elevators learns to be at your service just in time. So in our team was Maciej and Piotr from Poland and Wolfram from Switzerland. So we are really an international team. I'm from Detmold, from Germany. And yeah, we started and we found out that we have some, let's say, maybe not key takeaways, but key elevators in our presentation. So the first thing is what we did to approach a kind of solution. We tried to understand first the challenge purpose as it is, so reducing waiting time, but also the challenge task for the hackathon, which is not already the final goal of the challenge, because the task was only to predict the next requested floor and not actually reducing the waiting time. The idea behind is clear, but yeah, the challenge was a little bit different. And the second point was we had to understand the data. So during this data understanding, we faced different scenarios, and we had to choose what is the relevant data for the task in rows and in the columns, because the data we got is a mixture of 16 different tables, just merged into one, which creates also some problems of duplicate timestamps, etc. And we had to understand what is the influence on the purpose and on the task. Next step was then to analyze the data, as also the other groups did. We spent a lot of time on data analysis, preparation, scoping of the right values. We cleansed also data, like the parking position topic we discussed as well. And we enriched also the data because we decided that the last 2 months of data is not enough for our learning model. So we need the 200,000 data base in order to get a good machine learning. We checked the data quality means of leaks, anomalies, and decided also what is our good data. Yeah, and finally we shaped also the data to the model we intended to use. So the files we got, we cannot just use as input data. So the shaping was also done. Yeah, then we created the solution model, and we decided for I'm a little bit late with my presentation, I think. Yeah, so our solution model is based on a recurrent neural network model, RNN, and the coding was done in TensorFlow with Keras API. I'm just reading now all these words because I'm not the hacker of the team. We use the prediction model, LSTM, so a long short-term memory. And maybe, Maciej, you can tell us a little bit more about it?
Okay, so this kind of layer in a neural network is used to remember the some it is used to find some patterns in data, and it's done by recurrently giving the result which we get from the recurrent LSTM layer again to the same layer, but as an input. So output of the layer goes to input of the same layer, and that's why we can create a chain of possible results. And that's how we approach to this problem and find a special pattern for moving for elevator moves. Yeah, so in short words, that's all.
Yeah. Thank you, Maciej. So what is finally also another key elevator in this challenge? The challenge was the team itself. So we really faced already a challenge in the team building because it was completely virtual, international, with people we have never seen before. We don't know them. So this was a challenge. And we have identified, let's say, 2 keys of success for a team in a challenge like this. So it's first the diversity of skills and roles. I just told you I'm not the hacker of the team, but we had 3 hackers in the team, and that was really good because they really created the solution. But even the input of the non-hacker was very helpful in the area of data understanding and also in, let's say, pitching or team building.
Sorry, can I interrupt you? Please keep an eye on your time.
Yeah. Thank you. And the last key factor was we have all a matching mindset. So we have a quite open mindset, and that was one key of success. For a short outlook and a recommendation maybe to finish contact, how to continue is our model is already quite accurate in this short and small database is maybe 45% is maybe not bad, but it's really depending on data quality and scope. And the recommendation to change the parking position would also be one of our recommendations. And also the parking position maybe should be different depending on the day on the daytime. So we included also the daytime in our model. And nevertheless, we have also some fine-tuning ideas already to the model, which was not possible to implement in our model in the short term of time we had. So I'm done.
So thanks a lot, Juliane, for your presentation and also for the support from your team. So it's great also to hear your feedback about the hackathon, about your lessons learned and so on. I think this is what it's all about. So it's not only about solving the challenge and making a perfect solution, but also to learn something new, new people and new skills, open your mind and this kind of thing. So I think it's already a great result. So maybe you could also share with us a bit more about the results, concrete results that you have achieved, about the accuracy of the prediction, and can you share us with some more details about the concrete results of your optimization or prediction?
So maybe I can help with this. Yeah, I actually don't have a camera, so I can't turn it on. But the final accuracy we got on a training set, it's about 55% of the next requested floor. Yeah, but we couldn't use validation set to do this because LSTM layers are quite hard to deal with validation sets. Yeah, and they are not working normally as basic dense layers, so it was quite hard. But looking for our loss function, it was linearly decreasing till 250 epoch. So we think that we didn't overfit our model. And actually, how we get this 2000 rows of data, we just make our own algorithm, which actually gets rid of all of data of requests, and we are basing only on timestamp and elevator movement. And basing on that, we created a separate column for a request which was based only on this timestamp and elevator moving, and we shifted it one position, to the one position backwards, so that we can take this column as a future request, So yeah.
Yeah, that sounds good, and I think it might be very interesting for Phoenix Contact. Maybe it also to provide a bit more or a bit better data, also to
Yes.
Do we have some questions from experts to this team?
Thank you very much, Juliane and Maciej. Your procedure on analyzing the data was very systematically, which is very nice. So basically, the same question, or my favorite questions, which I also had for the other groups. How would you translate your work and results to the elevator? What is needed for the application to see the results on the final elevator?
If you really look on the real life of the elevator, there are, let's say, three actions I have in mind. It's the parking position recommendation to put it from basement to the second floor is a great one. I already mentioned. Maybe at daytime later on you should move it to number 5, but a detailed discussion. The other point is how today the data is collected is not reliable enough to have a good prediction learning for the future. So we had a lot of leaks in the data, so missing requests, and maybe this 5-second cycle is not the right way how to collect the data. That's to be seen. And maybe also from the data cleansing point of view, we can get maybe other kind of data. So that would help also to the model to be more precise. And then I really think we can reduce the waiting time. What for the waiting time is, from my point of view, not interesting, and we discussed it a lot. The inside requests are not reducing waiting time, just the outside request. When somebody is standing outside the elevator and presses the button and the elevator has to come from somewhere else, this is should be the main scope for the machine learning. But if we only take those records, the database is just 500 records, and that's not enough for the challenge currently. But with the time, we have more data, and then would help, I think.
Yeah, thank you very much. So, basically there is also some potential for improvements by changing the data acquisition, making some adjustments to it. That's a good feedback. Yeah.
I think already the merging of 16 tables to just one was just creating a lot of bugs somehow. Yeah.
Mm-hmm. Yeah.
Okay, so thanks a lot for the discussion, and again for the presentation. It was it's interesting to see so many to the same time. So I think it's also quite interesting, also for the challenge providers to think about it. I think there are several already, let's say, points where they can really think about how they can improve it, because I think there's a lot of room for improvement. So again, thanks a lot. And I would suggest to switch now to the next challenge. So we are done with the building challenge, and now we are going to the city challenge. And maybe I think it would be also interesting because we have all international teams. So maybe everyone can also just briefly say something about the team from where you come from, and just that everyone can know it to be very nice. So Anna, you can just play the Smart City video, and then we can switch to the pitch of the team.
Hi, welcome to the AI Challenge Days. I'm Jens Peter, Project Manager of Lemgo Digital. Lemgo Digital is the open living lab of Fraunhofer in Lemgo. Together with city authorities, with citizens and with industry, we develop smart city solutions for the benefit of the people living here.
In Lemgo Digital, we gather and collect a lot of data, and that makes it a perfect development area for data applications, and that is where you come in.
A very good example of data that we are collecting is parking. These sensors are detecting whether a parking slot is occupied or not. We are using this data for parking information systems, as well as a traffic information and traffic management system in Lemgo. All these data is sent 7/24 to the gateway that you see here above. You have seen a larger parking area before. Here we are in an area where we have side parking spaces alongside with the street. For the people searching for an open parking slot, it is of less value to understand and to know whether a parking slot is occupied now when they still have many minutes before they arrive. So for them it is of importance to know what the prediction is, whether a parking slot will be free when they arrive at the specific area. For this challenge, we have chosen this specific area where we have side parking slots, which are detected by the technology that you have seen before. This is an optical sensor which is detecting all the different parking slots on the other side of the street. We are providing to you the data from 2019, the occupation data, how often and in which frequency the parking slots are occupied and used. And we ask you to predict, based on the existing historical data, how the usage of the parking slots will be done in January and in February 2020. And your challenge is to develop a prediction algorithm that helps us to develop a parking management system.
Okay, so thanks, Arne, for playing the video for a challenge. And now I would like to welcome the team Smart City, Arnab with his team, Mazumek and Chris, to present the result of their team for the Smart City Challenge. Are you guys here?
Yes. I think everybody can see my screen. So first of all, I want to thank you, that organizer, to organize such type of event. But it's a remote event, it's not an in-person event, so there are some pros and cons are there also related with this event. So we have faced some challenges also in this scenario. So
can you just turn on your camera?
Okay. I'm sorry, it's not able to detect and detecting.
Okay.
So,
okay, you can move on. Thanks.
So that goal of this our problem is that parking occupancy prediction for hourly time periods in Lemgo with some AI technique, because it's an AI hackathon or AI challenge. And just like the previous teams, like in other challenge, we have faced a lot of problems in the data. Like mostly the data cleansing, we spend a lot of time in the data cleansing. And we want to make sure that during the data cleansing, everything will be fine, so that our approach can be transferred to next step to do that some work. So we divided our task into in 6 parts. First is data preparation, then identifying the task, and then trying to map with that machine learning or AI task, then finding the proper model, then trying to find that loss function based on this the documentation, and then some learning algorithm, and next is the evaluation. So we are quite successful in this area. So we spent a lot of time to clean the data. It was more than 440,000 data points are there, and then we came up nearly about 2,600 data points. And you can see that this type of representation we received during our training and validation dataset. And it is a regression time series prediction. So you can see from this data point, our training and validation data point, you can see that picture also. So we have to predict some sensor value. So there are a lot of tasks are including between this thing, like to check that sensor can be faulty. So that we need to check and other some information. And then we have found that LSTM and can outperform rather than any available RNN that machine learning algorithms family of RNN like LSTM GRU can outperform best. But as I mentioned, that there are some pros and cons in this type of event. Like though we are living nearly, but we are communicating through internet due to this situation. And from today night, we are facing a lot of challenges to do this. So how we proceed in our approach? First, we started to cleansing the data, and it has a lot of steps are there. A lot of steps are involved in this area, and accordingly, we are trying to test our methods also during the data cleansing, during some different methods, collaboratively. And then we are starting to creating a model with this machine learning algorithms, and then we faced the challenges, and then we noted the challenges what we faced that can be transferred for the next steps. And you can see from this screen that in the loss section that the mean error square error is for ARIMA is 5.553. And we tried with LSTM also, but we are using Google Collaboratory to execute our code and share the data among the team. And there we faced also few challenges there regarding the connecting issue and execution issue. And here is some model prediction and loss function prediction results are there. From the LSTM that we choose 50 epoch and we end up with 0.032 loss. And from the ARIMA, you can see like we perform some hyperparameter tuning to find out some good results in between some data sets. And we came up with best ARIMA is 4.4, sorry, that 3 parameter related with the ARIMA is giving this less mean square error. And we could not provide that output result yet, so it's still running due to the network issue, but I think we can provide when we will execute that code after that. Thank you. And one thing is that how we can realize our approach, like executing our code with the data point, we can get some predicted data and we can check with the real data, real world data, that we can realize our approach.
Mm-hmm. So thanks, Anna, for the presentation. Maybe the first question is, how did you approach this problem? Because there's probably a lot of possibilities to solve it. Because I think you was also struggling in different ways of approaching it.
Yes, the first thing is that I mentioned, identify that if you see this slide, the second part is the task. So first is that to identify that what is the problem, real life problem. And then there are 2 types of scenario we can go. And then based on the discussion with the expert, we decided, okay, this is the approach. And then we are trying to find out that what is the relevant or possible ways to solve this problem. As for example, within some in a date, within some hour, there are multiple transactions are there. Like some car came to the parking slot, left, and then you are trying to find out how many cars are available at hourly basis. And then there are 34 sensors are there. We are summing up with all the 34 sensors at each hour, at each date. And then we checked, you can see some results are here in that description. That is the training and validation data, but it's after cleansing. Then we can check some records are not relevant with this information because it seems that sensor is faulty. So there are very huge differences. So this type of information we analyzed, and then we come up with, okay, this is our data set. But in our data set, you can see we have only multivariate time series. So it's really hard to use some deep learning model, but using this with also with that minimal less number of data points, training data set. But with this scenario, we have found LSTM and ARIMA can outperform in this
Okay, understood. So I see there's some question on YouTube channel. Can you give us some more details on the needs for clean up the data? So I think this clean up of the data, I think it was one of the biggest issues for all teams. But any details about that from your side?
Yes. So
which needs could be cleaned up, or some ideas how to clean up this data, or?
Okay, so here we used Pandas data frame, Python Pandas library, and there are a lot of joining, grouping we have to do for this clean up the data. So suppose the transaction start with 1st September at 0 hours, and then 0 to 1 hour, there are a lot of entries are there. Sensors are occupied, some sensors then are left from that time slot. All logs are there, and then we are come up with how many sensors are occupied at 1 o'clock. Then similarly at 2 o'clock on same day. In that way, we got the difference, and if this card is occupied, then we took the positive number. If card is free, then we are setting this one to 0. Then you can see, like, in one date and after 23 hours, when you have car occupied, it will go to next day. It will be same day. So we have to add that logic also. And in that way, for all 34 sensors, we come up with at one day, at 1 hour, how many cars are occupied in that parking slot. So there are a lot of grouping and joining all different type of data that involved. And then we come up with some information, but still you can see some information is, you can clearly see from this graph that it you can consider as an outlier, because there are 34 parking spaces are there, but some sensor is showing 200 or something like that. Then we drop that information because it's not possible. Then we have to understand, okay, might be that sensor is faulty.
Okay.
So in that way.
Okay, thanks. Is there any question from our experts that are also in a...
Yes, I would have a question. You decided...
Alex, can you just turn on your camera?
Yes, sure. Sorry. You decided to use LSTMs. What can you say about the amount of available data and the risk of overfitting?
Honestly speaking, that amount of data is like for training and validation set 2663, but we are using Google Colaboratory to execute our code, because we are, due to this scenario, we are working remotely, and we could not execute the data within that time. So fast data, when I am trying to execute the LSTM model, it took near about 1.5 hours, and then suddenly I disconnected from the internet. Then I have to execute, and I received after 2 hours. So it is taking too much time. And then you can see this information into that epoch loss here. So it's too much time. But after that, I again got disconnected. And the problem is in Google Colaboratory is that if you are disconnected, you are restarting your session, then you will lost the files and information. That I faced that challenges here. So in this scenario, then we moved from that approach to machine learning approach, and there are different methods are there. We tried one method is there, that is Holzwinter method, but we didn't get much result. I mean, didn't get less MSE. So then we checked with ARIMA method, and that's the thing we mentioned here. And then when we are working on the ARIMA method, we can select any value, but the thing is that we need to find out some preferable parameter, and that time we try to use hyperparameter tuning based on some data points, and then you can see the result, the best ARIMA data point. But why you can see here, because it's not completed, because I have to stop that information, because after minimizing this MSE, it is still increasing, but it's still running due to network issue. That problem we faced in this type of event.
Okay, thanks.
Okay, thanks, Arnav, and thanks for the discussion of all the experts. So I would suggest now that we switch to the next and the last challenge, which is the industry challenge. So Anna, could you please just play the video of the challenge?
Hi, my name is Marta, and it is my pleasure today to welcome you to the AI Challenge Days in Smart Factory OWL in Lemgo. Our challenge to you is develop an AI-based system for anomaly detection in 2 smart factory production systems. You see, anomaly detection is one of the main research topics in here. Why, you ask? Because it's all about the machines in factories breaking. And you know, when a machine breaks, or just a part of the machine, then we are facing downtime and we are facing high repair costs and, in general, increased costs. But what if we could pick up this tiny minute signs that the machine is going to break from the data that we are getting from it? This is the versatile production system. It's the first machine that you will work with. It is a modular production system which produces packaging material out of popcorn. It is modular, so every module that you are seeing here performs different function. However, what will happen if here, in this module, something happens? Let's say the extruder, which is located here inside, let's say that it stops working. What will happen then? Well, obviously this container will fill up and there will be nothing going into the next module. And how can we detect this? This is the conveyor belt system. It's the second machine that you will be working with. Its task is pretty simple. It is to transport a piece or a product from bottom right to top left using conveyor belts. The conveyor belts are equipped with 5 horizontal motors and 2 vertical motors. In here, the data that we have available is coming from the energy meter, so it provides us with voltage, the whole power consumption of the whole demonstrator, as well as the PLC sensor data logs. So, your task. You are going to get data logs from us, from both the machines, which contain both normal behavior and faulty behavior. Your task is to develop an AI-based algorithm that will tell us exactly where the faults are. I wish you the best of luck, and I'm looking forward to see what you come up with.
Okay, so Anna, thanks for playing the video, and now we can go to the first team in the challenge industry. So Mike, Prana, Chan, and Valdemar. So it's your turn now to show us your results.
Yeah, I will share my PowerPoint. So yeah, don't be so strict with us with our PowerPoint, because like we're all kind of engineers, so the design is not the best.
Looks great. Looks great.
Okay.
So
yeah, our team consists of, yeah, like I said, engineers. We have PhD students. Mike also has his PhD, so we're kind of computer scientists and engineers. And we already saw, why is it not working? Yes. We already saw our 2 use cases in the small introduction. One of them was about the conveying belts, where I can transport physical objects, and the other one was the production line. So we had 2 data sets or 2 problems, and wanted to detect anomalies which can be different in the 2 data sets. Our main method or main approach or thought was to follow the CRISP-DM method. So we wanted to understand the data, we wanted to understand the business problem, and then follow up from pre-processing, modeling, evaluation. The data sources, like it was also mentioned in the movies, were about energy meter measures or other sensor data. First of all, we did a lot of visualizations about the data and about the data points itself to compare normal process cycles with anomalous process cycles, and then we considered every process cycle as an experiment, which is time dependent. So it was not a time series like in the other challenges. It was more like that we had 50 experiments, which is one experiment is one process cycle, and this inside of the process cycle we have a time dependency, but not outside of it. Yeah. Afterwards we did some research. Also found a lot of papers where anomaly detection is used. Most of them are divided in like normal machine learning approaches as well, in supervised, unsupervised, and semi-supervised algorithms. We tried them all kind of, so it was an experimental approach. Also, we tried to use statistical process control, which is out of the area of lean management or Six Sigma, to find some outliers. They were all working okay, I would say, but the holy grail, how we solved the problem, was not to take some algorithm and throw it on the data and hope that something is coming out. It was also to look into the data and maybe also find some patterns by, I would say, eye, maybe. And that was our solution. So we did kind of a rule-based approach, and surprisingly we found that if we have floating points in integer data, there are anomalies. That was the first anomaly that we found. The second anomaly was if the experiment, like I defined it before, if the experiment is over 15 seconds, we also have an anomaly in the data. And with this rule-based approach, we had our best results, which was kind of surprising. But yeah, as I said before, we're engineers, and yeah, this solution was the best, and it worked. So it's not only the AI or machine learning approaches, in our opinion as well, it's that you have to think kind of out of the box as well. Yeah, that was kind of our result. And then, yeah, because of due to time reasons, we had not that much time for the second use case, and thought about to implement a kind of automatic modeling process where you can choose different machine learning models if you have the input data, and compare the results, and comparing the results with an evaluation criteria, which was the ROC curve. And in that example, the random forest approach for the production system was sufficient. And but you can, like, the method to automatically find the best model can of course be extended. Like, we can use more models for it. We can also extend the evaluation criteria, so that we just want to look for the accuracy or for the F1 score, for example. And yeah, that's basically it. The next steps would be definitely to think about the deployment. So is it better to host the prediction models into a cloud? Is it possible to optimize the hyperparameters of the models? For example, we use, or it could be possible to use Bayesian optimization, which is way more effective than, for example, grid search or something else. So there are a lot of improvements possible, and we're still not at the end, I would say. So yeah, thank you much for your attention, and if you have any questions, feel free.
Yeah, thank you, John. Very nice slides, even though you have 4 engineers, and I think that you could really feel it, that you have really a systematic approach to the problem. You have analyzed papers, so I would say even scientific approach. I think it's very nicely done. So maybe before we step into the technical questions, I think you have also an international team. So how have you guys organized yourself? Because I have seen that you was, I think, on some other platforms, not on our platform. So was it a challenge?
No, it was not a challenge at all, because we all live in Germany, so the time zone was not a problem at all. And we use Teams, so we continued to use Teams, and had our notebooks in Google Colab. So this was also not a problem at all. Yeah.
Okay, great. So do we have some questions from the experts? So I guess that Alexander.
Yes, of course, I've got some questions. Thank you very much for your presentation. It was really interesting, and I liked your out-of-the-box approach. You said it must not be the most complicated way to solve a problem. I also saw one presentation at a conference. He did some predictive maintenance on some robot, and then he just used some linear approximation to predict the time of failure. And then he said, maybe you are disappointed that I'm not using deep learning, but why should I use the complicated way when it's possible to do it easy?
Definitely, yeah.
But the easy use of machine learning, you said it in one sentence, but why is it not possible to just use one standard machine learning approach, throw it onto the data and get some results?
Like especially in industrial processes, you have a lot of dependencies in my eyes of different systems, and you have to, like, normally you're saying domain expert, but in my opinion, it's not only that you have to know the domain of industry, it's also really important to know your process, like your kind of production process, and that's like the most important thing. So yeah.
Okay. Another question regarding the second use case. The slide is still online here.
Yeah.
How did you deal with the timing information?
So the timing information in that case was, we also considered as an experiment, but maybe Prana, you know it. I'm not sure whether we also divided it again, that we have like the experiments in the pre-processing.
So for the production system, I think we used time as an input to the machine learning models, and in the conveyor belt system, we did not use time as input, as it was more based on the sensor signals whether there is an anomaly or not. We also used a time approach, but yeah, at the end we got an out-of-the-box solution, so we did not spend so much time on whether to use time or whether you not use time. We also tried different approaches before, but at the end we had a look at the data and then we found the solution for the conveyor belt. But for the production system, I think there still needs a lot of research, because we are not like we are not sure about the process itself. Maybe if we know the process better, then we can modify the problem statement accordingly, and we can process the data and accordingly, and then we can proceed with that.
Yeah, like that was the problem in my eyes as well, that like of course we had the data in the production system, and like I said before, we took that was not our main approach, but in the second use case we took the data and throw it into the modeling, automatic modeling, and had like 5 or 6 models. Here it's 5, yeah, and then we saw, okay, the random forest is the best, but it's like there's no process knowledge inside. There is so there's nothing inside, kind of, because yeah, due to time.
Yeah, in the time we had, like for this problem, like for the other problems, I think it's easy to understand. But for a production process or industry-related AI, then it is all like it requires time. 2 days is not sufficient in our opinions.
Why I'm asking, I think many problems in production systems can be found via the timing information, that one process is lasting too long, for example, due to wear of some conveying system or something like that.
Yeah.
And I'm not really sure whether you can find these anomalies with a standard random forest approach, because you have to analyze the relative timing between two different discrete events.
Yes, we tried those approaches. Like we tried autoencoder approach. Like we are comparing the input to like reconstruction based approaches, where we reconstruct the input and we see whether the score or the reconstruction is close to the input or not. And we train the model based on this reconstruction, and then we compare. When we have an anomaly input, obviously the output will not be the same as the input. So yeah, we did try autoencoder based approaches. Like we have here Keras model in the plot that is on the screen right now. That is an autoencoder based approach. Definitely.
I think, but it's also a good point that like what Alexander said, because okay, we have the random forest here now, and it's like a good performance, but we also have to question about whether it could be like, is it really the truth, or is it like, do we have to dig in a little bit deeper? So yeah, I can understand the question, definitely.
Yeah, the thing is, we can like, as per my knowledge, in the production system, each module is different. So we could divide the whole data set into different. For each module, we can have different data sets, and then we can see which module has an anomaly or something like that. Yeah, we can we can modify the problem statement accordingly. Like data analysis is required.
Okay, thank you very much. I'm looking forward to see the evaluation results.
Okay, guys, so thanks a lot for the presentation again, and thanks for discussion. I think it was a very nice idea and promising approach, and very systematic, as I said. So let's see how the other team solved the same problem. So we have Ovidiu, Juan, Vivek, Abhinay, and Kavan in this team. Are you guys here?
Yeah, hi everyone.
I see a video here. Okay.
Yeah, I'll try to make a presentation for our team. So let me know if you see the presentation. I just need a small confirmation.
Yes, we can see it.
Great. So yeah, indeed, we have been a team of 5. Unfortunately, Juan could stay only until yesterday afternoon, but he provided also some valuable input to our team. We also, as like Team Chan, we try to find solutions for the 2 anomaly detection problems. So as already mentioned, there were two systems to be analyzed. One is a conveyor system and one is a production plant. What we have observed as the main difference, let's say, between them is that in the conveyor system, we are having failures, but we had also to find out the behavior modification. The production plant had almost only failures. So, for example, in the conveyor system, the high power consumption is a behavior modification. So this is one of the main differences, but we are having many others when we went into the exploration of the data sets. So we in terms of organization, we were split in 2, and we made analysis of what is happening there for the data conveyor. We have observed that the data sets are labeled, that the training data set has only error-free cycles. And we have also noticed these correlations between the voltages and the power. Yeah, whereas we are having a relatively small set of features, I would say here. Yeah. On the other side, for the data production, we had no data labeling, so this was a bit confusing for us at the beginning. I have to reckon. All features have the value 0 or 1, and therefore we did not find any high correlation between any features, and we had to consider all features for training except the timestamp. Yeah, and I will say that that was the main big difference. For the conveyor system, we had also to normalize the data. As I said, for the production system, we had only 0 and 1s. Now we took decision on them, so and decision on how we would approach this, and we basically say, okay, there are different types of algorithms that would match for each challenge. For the conveyors, we decided to go with the PyOD library. Because it is quite comprehensive on the number of algorithms and research algorithms in the area of anomaly detection. Whereas for the data production, our decision was to go for a complete unsupervised learning solution with neural network. In each case, we had 4 types under analysis. So for the data conveyor, we had the linear model, so the PCA, although quite old, we were quite surprised by the results we will see in a minute. We had the proximity base, mainly we tried with KNN. We had the outlier ensembles, we tried here with iForest, and we also tried with RM, unfortunately, we not with good results. For the data production, it was way more complicated. Actually, it provided us quite some headaches yesterday because we had quite big expectation, especially when it comes to deep autoencoding Gaussian mixture. The rationale for this is the MOGAL and the DAGMM are able to use a finite number of data points as we have had here. So as in all the other challenges, unfortunately, we didn't have very many data points, but on the other side, it is clear for us, and it is a known problem in the industry, that the anomaly detection has generally an issue of having enough data points. Yeah. So after long analysis and trials yesterday with DAGMM, we unfortunately had to drop this solution due to the time. If we would have more time, we would extend this research in this area. We have managed to perform MOGAL, but since we have performed MOGAL on the data point and we couldn't do it on the cycle level, also I wouldn't say that the results are conclusive for our analysis. So eventually we stayed only with the autoencoder and the variational autoencoder, and we moved into these 2 areas. Yeah. So these are the algorithms that we have experimented with, and now here you can see the results. It is worth to mention that again we are having a big difference between the 2 types of challenges. Let's put it like this. So for the data conveyor, since it was labeled, we had an external validation, so we could perform external validation and we could calculate the precision and the F1 score. As you can see, the results are quite different. We had 3 types of executions. So we performed ones without data normalization, we performed ones with data normalization, and we performed ones without data normalization but with statistical feature extraction. And the best result that we have obtained with is with PCA. So we had a F1 score of 83% and a precision here of 81%. You see the confusion matrix down there. So I would say it's not ideal, but it's still a good approach for the small time that we had. Probably, in my opinion, the KNN and the iForest would bring way more if we would have time either to extend the data with synthetical data, or we would have more data points and to see. Probably we have made also some mistakes in the execution or in the experimentation process. This is why we are having a strongly underfit result. But I'm trusted that these approaches could be also analyzed further. If we are going on the other side, on the data production, so here we have used this ensemble of autoencoders, and this ensemble has been employed just to learn the error-free training data distribution by encoding them into a low-dimensional latent representation. And with this, we have reconstructed the data points back from the latent space. So what this brings is that we are having basically a bottleneck layer, which tries to encode the error-free data distribution in a latent space, and it tries to reconstruct from it. And the main idea is that when an erroneous data point comes into this, then the reconstruction loss might be significantly high. So you can see it here in these graphs. And we created histograms of reconstruction losses from this autoencoder for every cycle that we had. And well, we have chosen the threshold for this cycle based on the validation data, because in the validation data, unlike in the training data, we had also so we had the erroneous cycles. And what we have done in order to select this threshold, maybe it's important to mention, we have split the 22 cycles into 70 cycles of training data and 5 cycles of validation data again. And this way we basically could find out which there is some noise in the background. So we could find out create the model to find out which cycles would be erroneous and predict the anomaly. And they are here, in the red one, you can see the ones that are anomalous, and in the green ones, they're the ones that are not. And we do not have an F score here because we do not have a labeling in the evaluation. We cannot say which one are the correct ones or which are the bad ones, but at least we know that there is a high probability that the responses are right, and we are having 11 outliers out of 24 found. Okay, so this is what we have done, but unfortunately, and this is why I put it here in red, there could be a lot of things done to improve our work and to improve our model. We need to think that we had not too much time. What we would like to have, first of all, is to improve on the explainability of the model. Let's not forget that this model should be used by people who are not necessarily aware of machine learning. So if I would come back to the initial requirements, people would like to know when a container is empty, or when we are having an anomaly on a high power consumption. We were not able to transpose this into this kind of responses in this very few time. And this is one first improvement that we would like to do here. The second, and probably also the equally important, is we would like to check a bit more with this generative adversarial networks for anomaly detection. We believe it's not only a sexy approach, but is a good approach, especially because we are not having too many data points. Unfortunately, again, due to time constraints, we couldn't do this. And yeah, as a general conclusion, I would say it was quite a challenging and interesting topic. We were a mix of people with different experiences from different parts of the world, I would say, although most of us are living in Germany and working for companies in IT. And I would like to thank to my team and in the name of my team to everybody here for letting us the possibility to work on these challenges these days. Thank you very much.
Great, Ovidiu. So thanks a lot for your presentations. It's really impressive, and you can really see how much work you have done in these 3 days. So it's really amazing, not only about only your team, but also all teams, how much job you have done in this really short time. So it's really impressing me every time I'm thinking about it. So congratulations. And yeah, so I think we have some technical questions from experts to you guys. So who would like to start?
I can start again.
Okay, Alex, thanks.
Yeah, thank you for the nice presentation. I liked it also as well. And I also have been very impressed of how much work you did in this very short time. You showed the correlation matrix and the PCA, which was the winner of the confusion matrix, but both are working in linear manner. What can or what did you do in regarding the non-linearity of the data?
So here I can also invite, for example, Vivek or Abhinaya. So what we have done is only to normalize the data. And actually, the algorithms and the script for normalization is put there. But maybe Vivek, you can explain a bit more here on the how we have done this.
Okay, I'm Vivek. With respect to data conveyor. First, we initially tried without normalization. Even with the linear PCA, the best model which is performing now didn't perform well at that moment. And then we tried with normalization. At that time also, performance is not good. So what we identified is the curse of dimensionalities, like number of training samples is 45, but for a cycle, if we stack all the features for one cycle, we are getting around 4,000 features. So total number of samples are 45, but the number of features are 4,000. So we felt that might be the problem for the machine to not learn. So what we did is we tried to reduce the dimensionality by extracting some statistical features like mean, variance, skewness, kurtosis, something like that. So the dimension is reduced. At the same time, the essence of the data, the structure of the signals, okay, or somehow captured in the features. So when we tried with that approach, we got the better results.
Okay, thanks.
Yeah.
A second question. The same as for the other industry team, how did you deal with the timing information?
The timing we have considered only for the data conveyor. We didn't consider it at all for the data production. So actually we have removed it completely from the features. We were unsure about this at the beginning, but we had this question and answering session, and we asked, and we get the response also from Professor Cishek that at least for data production, this is not needed. Yeah. I have to reckon this is particularly important probably in data for the data conveyor. When we are having a behavior modification. So over a specific amount of time, we need to see what is the behavior. What we have done here, and probably this is also not perfect, but if we are looking at the data and we are seeing the labeling, we can see that during a specific cycle, at a specific time, so the specific data point, we are having an error or not an error. And usually a cycle which has at least one error, one data point with an error, we can consider that the cycle had an error. The cycles that had no errors inside the data points then have no error. What we didn't do, and this is again is something that could be enhanced, is to look at the behavior modification, in the sense that we are looking at the change into the one, so the error, and now coming back into the zero, so no error anymore, and see how this modifies over the time. This is something that could be do over and based on analysis of the time feature. Yeah.
Okay, thanks.
I have also a question to both teams. How would you implement your models now in on the systems?
So, in my opinion, it is very important to have a feedback system. So the basic model implementation can currently be implemented. So we are working at the data point level. We are not working at the data batch level, which is good. That is, whenever a new data point is coming into the model, it is able to analyze, and it knows it's a new cycle or it is the same cycle, and it takes a decision. What we would want to do even more when it is productionalized, let's put it like this, is to create a feedback mechanism. That is, a human is able to say if this was truly a problem or not, and we need to correct, especially the true negatives, yeah, and the false positives. And this can be done only by having more and more data points and by having a feedback mechanism. So this is something that needs to be done when implementation.
Can you would like to also answer this question about your team?
Yeah, like you can also extend the approach, and you can say, okay, let's say we have a prediction, but our model is not confident enough whether it's true or not, like whether it's an anomaly or not, let's say it like that. Then there are also approaches, like Ovidiu also said, that you can use in research it's called Oracle, that you can use a human who is then giving you the right label. And so it's kind of an approach where you're using the model itself and an Oracle aka human who is helping the model out if it's not confident enough whether the prediction is right or not. That would be a possibility.
Okay, thank you.
Great. So I would suggest that we stop here with all the presentations to not get more from your remaining weekend time. I'm really amazed about all the presentations and all the results that you have presented. Really, all teams did a great job, and we were not expecting that we will see so impressive results at the end. And we are really happy that all 6 teams are from the beginning with us and finish their job. And it's really amazing experience for me. I hope that also for all of you guys. So really, so motivated people working on a weekend. Really big respect to all of you. So maybe just some information about how it goes with the challenge. So as you know, we will now have a time for evaluation. So we have already scheduled the next meeting on 15th of June at 6 p.m. Central European time. where we'll say who is the winner of the challenges. So I hope that all of you will also join that and hear who got the prizes. So as you already said in your presentations, you would need some more information about the machine, the data, and so on. So maybe you will have the opportunity to come to us and to work with the machines, to try it out there, and to bring it to the end. Yeah, so it could be also your first reference, for your new business, for your new startup. You can use it for whatever you want reasons in the future. I think it would be a very good opportunity to have something like this implemented in reality. We will also make sure that we make enough promotion to your results in, let's say, media and also among the different companies. So I think it's also a good multiplicator for you guys to present yourself, to present your skills, to present your ideas, to the professional people. So I would maybe suggest now to bring up the whole organization team to turn on the cameras, and maybe also every one of you who would like to share also your camera with us to turn it on. Like we said in the beginning, so the community, AI community RWL, this is an open community for everyone. So we have just started it, a couple of months ago, and hope that it will grow. We would like to keep it international, so everyone around the world who would like to join is open to join. We hope that also the companies, we already got a lot of likes on social media from really big players like VW, I can think Siemens, and also from the Ministry of Digitalization from NRW. So they already see this event. So I hope that we'll get more attention also from the companies, so there will be also more challenges to be solved. Like I said, feel free to participate in the community. You are also welcome to take an active part in that. So we have initialized it, but everyone can really actively participate in it and shape it up with us. Right now, you can follow us on Twitter. So maybe Thomas can just share his screen so that everyone can see the channel. So if you have not follow it yet, so please follow us on Twitter. Like I said, share with us your opinions, your feedback, and just create this very exciting topic with us together. So you can see here the Twitter channel. So we have already a couple of followers. So we hope that after that event, we will have a bit more, and we'll also get more attention from more people, industry, startups, and research organizations.
So please feel free to join us, and you will find more information on upcoming events or what we're going to plan in future. So we will bring up some more channels as well, but the first one is the Twitter channel.
So there will be for sure a next event in the near future. So we are now screening the companies that would like to offer some challenges. So events in the future, it will be not only hackathons, it will be also some different events. If you have some ideas, what kind of events you would like to see, just let us know. Just write on the Twitter which kind of formats you would like to that we organize, and also you feel free to join, and organize it with us. Yeah, give us some feedback. Tell on social media how did you like it. Share your experiences. Yeah. Thomas would like to add something.
Yeah, thanks a lot thanks a lot to all of you. It was really a pleasure to see what's going on, what's possible in just the 2 days. Sorry for not having that much sleep. I've seen from some teams, but actually this is like hackathons are always are. So we are looking forward to next upcoming Monday, not the Monday tomorrow, the next one, and to see the winners, and maybe if someone has an idea to provide another challenge, so please feel free. So maybe we can have another challenge with you, and I'm really looking forward, maybe after the virus we will have an on-site hackathon in OWL. So thanks a lot for all of you.
Take care. Good luck, and see you on 15th of June on our winners event.
Thank you. And then now you go and grab yourself some coffee.
Thank you very much.
Bye-bye.
Thank you. Bye.
Thank you. Bye-bye.
Thank you. Bye-bye.
Bye.
Thank you, guys.